So what we are doing is question number 7 at the bottom of the homework page. It says, how many molecules is 1.74 grams of magnesium bromide? Again, one of the keys here is it gives you the written name magnesium bromide. What I would have to do is figure out the formula for magnesium bromide. So, let's see here. Magnesium, that's a +2 charge. You can look at that column. Bromide, well, bromine is a halogen. It's the second to last column. It's a -1 charge. How I would start off a problem like this, so we're reintroducing mole conversions to you today, is I would write down the number given, 1.74 grams, but then I'd write down the formula of MgBr2, so I know what I'm working with. Again, how did I figure out MgBr2? Magnesium's a +2, bromide's a -1. I can either say to myself, I need 2 bromines to match up with that 1 magnesium, or I do that cross and drop method. Either way, it can get me to that value. Whenever we're given grams in a mole conversion problem, we want to first convert that into moles. Hopefully that makes sense to you. 1 mole over blank grams. How do we figure out the number of grams? How do we figure out the grams that goes in this conversion right here? Do we remember from a couple weeks ago when we started doing mole conversions with individual atoms? Emily, where do we look to find that value?
The red number.
We're looking at the periodic table, right? If I look at the periodic table, magnesium has a mass of 24.31 if I round it to the hundredths place. Bromine is 79.90. Kinsey, should I just add up those 2 values to find out the mass of magnesium bromide?
No.
What should I be doing also?
Using the values of gases.
The noble gases?
Yeah.
Well, the noble gases is why we have the charges that we do. When we look at that formula of MgBr2, how many magnesiums are in that formula? 1, right? How many bromines are in that formula? 2. We need to multiply this bromine number by 2. So then we can get our actual total amount of MgBr2. So unlike early in the unit, when all you had to do was look up for 1 individual atom and put its mass here, which, by the way, this value is called the molar mass, the grams per mole. Now we have to actually figure out what goes in our conversion. Again, we build in this class. I get a number of 184.11. That's what goes into the conversion. What makes this next step that we're going over a little more tricky is that we have to figure out our conversion. We have to calculate what goes into a conversion. And before we said to look at the periodic table, there's a number, write it down. We have to do a little bit of work for that now. And what I see happen with students sometimes is now that we get to this point, they mix up what goes into a conversion and what starts off the problem. Whenever you do any type of mole conversion, my first suggestion is immediately write down the number that's given to you. The conversion itself, that's an equality. There is 184.11 grams in 1 mole. Now recall, this would allow grams on the top and grams on the bottom to cancel out, and I'd be left with moles of MgBr2. When I look back at the question, it asks for how many molecules is this? Molecules are treated just like atoms when it comes to mole conversions. And there's a big number that we use to get to atoms. 6.02 times 10 to the 23rd. It's the same for molecules. So the good news is you don't have to memorize a new number for that. Quite frankly, you don't have to memorize Avogadro's number anyways. It's on a flag in the back of the room. Now, what I would do is I take my 1.74 grams and I divide it by 184.11. Then I multiply by Avogadro's number and I'd get a big number in my calculator for my final answer. Have to pay attention to sig digs. So hopefully when you type that in, you would get 5.69 times 10 to the 21st molecules. Recall if you had like 5.72, that's fine, times 10 to the 21st. Unfortunately, there is no abbreviation for molecules, because if you try to abbreviate, you're probably going to be turning it into moles, and moles is very different than molecules. Remember, a mole is a handful of something. Atoms and molecules are the tiniest things, like a molecule of H2O is one single H2O. A molecule of NaCl is one single NaCl. What my plan is for today is we need to practice this math for a little bit. We'll review trends for about 10 or 15 minutes, and then we have to introduce a new type of naming and remind you about this math as well again. So today is going to be a day where we need our calculator and we need our periodic table a fair amount. Because what we are going to introduce to you today is some metals on the periodic table, when we do our naming, they have more than one charge. That's why we're dealing with metals with multiple charges here. When you guys did the practice problem for the mole conversions with silver sulfide, I told everybody silver was a +1 charge. Well, here's how you can find out. Silver is number 47 on your periodic table. Why don't you find it? Then directly above the Ag symbol, what do you see directly above the Ag symbol? A number 1, right? That number 1 represents that silver has a +1 charge. Quite frankly, look at your alkaline metals. Beryllium, magnesium, calcium. What little tiny number do you see directly above all those? A 2, because all of those have a +2 charge. When I told you to write a big +2 above beryllium, that was just a big reminder. The tiny little numbers directly above the symbol actually tell you the charges of these metals. But go right above silver and look at copper. What do you notice when you look at copper, element 29? It has more than one possible charge, doesn't it? Copper can be a +2 charge. Copper can be a +1 charge. This is where things get a little tricky. Now, the first thing I'd like to do is demonstrate to you that there is a difference between those two versions of copper. I can do that 2 ways. The first way is I'm going to pass out for you to look at, not to touch, 2 compounds that contain copper and chlorine. This is copper with a +1 bonded to chlorine, so grab it and then pass it back. This is copper with a +2 bonded to chlorine. As some people are seeing that, I can remind you of the safety data sheet. Copper 1 chloride, which is the first one that you're going to see when it's passed around. That is really dangerous stuff. When you see the skull and crossbones on a safety data sheet, that's an indication of, ooh, actually we don't even use that compound other than for me to pass around for people to see it looks different. I mean, Gene, what color do you think that is? Not a pretty one. Boy, Gene, was that a horrible qualitative observation. Charlie's, what color was that? Yeah, that's a light green, maybe lime greenish, but then definitely different color for the second one, right? They look different is what I'm hoping that you see. Safety-wise, copper 1 chloride is acute toxicity if swallowed. Copper 2 chloride, so the second one that you're seeing, well, it's harmful if swallowed, but ladies and gentlemen, there's a difference between toxic and harmful. So not only as you're looking around, do you see that they look different, but they behave different as well. And that's the point that I wanted to make here to start off with, that these metals in the middle of the periodic table, some of them can have more than one possible form, more than one possible charge. And because of that, we have to indicate how they are different, because if we don't, we could be working with something that's potentially hazardous or potentially fatal. So, first thing I mentioned is if we check the small numbers directly above the symbols, we can see if they have more than one charge. The good news is those metals that are in the first and second column, the alkali metals, the alkaline earth metals, they only have one possible charge. The only time this is possibly going to pop up are the metals in the middle of the periodic table, like copper, for example. Now, if you ever on your own want to ask why do they have more than one possible charge, I can explain it to you, but it deals with electron configuration. And that's something that is a little beyond what we need you to know for this class. However, some people might be curious about that. What we are going to do, and I don't know if you even noticed it on the containers themselves, is there's a way that we can name these compounds to indicate the charge of the metal. And that's using Roman numerals. So what I want you to do right now is on your periodic table, how about like right on the bottom, or you pick where you want to do it. I want you to write down Roman numerals. If you don't know Roman numerals, here we go. There's a Roman numeral for 1, 2, 3. After 3, things get a little weird. The Roman numeral for 4 is an IV. It's the number 1 Roman numeral that people screw up. Then 5 is just a V. 6 is VI. 7 VII. 8 VIII. We actually will not need to go any higher than 8, but I've just numbered 1 through 8. The reason why we need that is when we start writing the formulas of compounds that have a metal with more than one charge, we use the Roman numeral to represent the charge of the metal. We don't use regular numbers, because regular numbers we use in formulas instead, like H2O. So Roman numerals will be used now. And not everyone knows the Roman numerals, so that's why we say, hey, let's write it down in the periodic table. Again, we finalized your unit test. The periodic table that you'll be given for your unit test will have Roman numerals written on them, so you don't have to remember it. It'll have the charges, +1, +2, -3, -2, -1, written on it as well. Again, we do this because we need to differentiate between these different types of compounds. On the way in, you picked up a worksheet that was titled Nomenclature for Ionic Binary Compounds Type 2. I'd like you to have out that worksheet. Again, I'm not going to read the top part of the directions. I'm going to go straight to the practice problems to show you what we need to do. The first question given to you gives you the formula of MnO3. In any type of naming problem, we either give you the formula and you give us the name, which is what this one is, or we give you the name and you give us the formula. If we look at MnO3, here's how I would approach this type of problem. Mn is the metal. That metal's name is manganese, so I'd write that down. Then I'd write down the nonmetal's name, oxygen. However, we don't call it oxygen, oxide, because it's the second part of the compound. And when I write down that second name, I'm going to leave a little space in between these two parts. Here's the reason why. Manganese symbol is Mn. It is element number 25 on your periodic table. If you look directly above Mn, what little numbers do you see? So Cole, what little numbers are there?
There's 2, 3, 4, 6.
That means manganese could exist as a +2 charge, a +3 charge, a +4 charge, a +6 charge, a +7 charge. Since manganese has more than one version, I need to figure out what version it is. If, however, there was only one charge for manganese, I'd be done. It'd just be called manganese oxide. Remember, this was the easy part that we had on the homework. Metal, non-metal, just name them and move on. Now it gets a little trickier. We need to figure out which charge it is for the manganese. And the way we do that is by knowing the non-metal, oxygen. Now, I had you write on your periodic table, above the nitrogen column, a big -3, a big -2 above oxygen, a big -1 over fluorine. I need you to understand something, that if you look directly above oxygen on your periodic table, all you see is a -2. That means oxygen is a -2 charge. However, some of these nonmetals have multiple little numbers directly above their symbol. For nonmetals, I want you to ignore those little numbers. Those little numbers will come into play second semester when we talk about something called oxidation states. But for now, when you were looking at nonmetals, things that have a negative charge, you only pay attention to the big numbers on the top of the column. Oxygen is a -2 charge. I have 3 oxygens in my formula, which means if I take -2 times 3, my total negative charge is -6. I have 1 manganese that can balance that out. Therefore, what must be the charge of manganese? 6. Manganese 6 oxide would be the name of MnO3. Again, what used to be the easy part for us of here is the formula, give me the name, is now going to require a little bit more work if the metal has more than one charge. Let's look at the next one. The next one is Cu2O. Tess, what's the name for Cu? Copper. We already know O is oxide. I'm going to leave a little space there. Mike, when you look at copper, what are the possible charges for copper? It's either a +1 or a +2. Because copper has more than one charge, we have to figure out which charge it is. Gene, the way we figure out the charge of the metal is by knowing the non-metal. What charge does oxygen have? -2. And there's only one oxygen in this formula, so my total negative charge is -2. I have 2 coppers to balance that out. So what must the charge of each copper be in order to balance out that -2? Okay, 1. Because if each copper was a +1, I have 2 coppers that are +1, you would balance out 1 oxygen with a -2 charge. This is copper 1 oxide. Third one given to us, CaF2. Sophia, Ca stands for what?
Calcium.
Calcium. Eileen, F stands for fluoride. Cat, how many charges does calcium fluoride have? I'm sorry, how many charges does calcium have, the metal? Its charge is a 2. Does it have more than one little charge above it? No, it only has one possible charge. Because it only has one possible charge, that's it. We're done with that problem. Because here's the thing. Some students would say, should I just put the Roman numeral every single time just to, cover myself? Always say the charge of the metal. The answer is no. Remember, we're in a chemistry class. We are the people that abbreviated a 4-letter word mole by dropping 1 letter. We are not going to do more than we have to. But we recognize that sometimes we have to do more than what we normally would have to do. I'll give you an example of this. If on the announcements they said, Haley Christensen, come to the office because your house burned down. There are 2 Haley Christensens in this school. So now, one person's being freaked out when they didn't need to be freaked out. Now, perhaps you hear it every now and then in the announcements that they'll say, this person, the freshman. Or they could use middle initials. There's a Haley C. Christensen and there's a Haley R. Christensen. One's a senior, one's a freshman. And I even asked the office staff this morning, I told them, give me a name that there's 2 people of in this building. And they even said, Haley Christensen, the freshman, hates coming down the office and then having to turn around and go back because it wasn't her. That she wishes they would just differentiate between the 2. Because if there's more than one version of Haley Christensen, they could use the middle initial to say, Haley C. Christensen, come to the office. Haley R. Christensen, come to the office. With copper metal, for example, there's more than one version, a +1 and a +2. We have to differentiate between the 2. However, if there's only one version of it, we don't have to differentiate. For example, if we said, Alec, come to the office because your house burned down, there's only one person with your same first and last name in this building, right? Why in the world would we use his middle initial if it's not necessary? And that's what I'm referring to when I go back to, where is that problem possibly? Not there. Not there. It's the next one. To this one. There's only one version of calcium. So why would we use the middle initial for that? Why don't you take a minute to do the bottom 2 questions on that first column? Write out the written name of MN203 and the written name of PDCl4. If we look at MN203, again, I would start that problem by writing down Mn is manganese and O is oxide. Again, I like to leave a little space between the metal and the non-metal. If I don't need to put a Roman numeral in, I'm already done with the question. But we've seen in a previous problem that manganese is a metal with more than one charge, so we need to include its middle initial. Oxygen, we've seen over and over again, is a -2 charge. So what I would do is take the -2 charge of oxygen and multiply it by 3 to get a total of a -6 overall. My manganese is positive. I need to figure out what's the charge of each manganese. And that's where the 2 comes in. If I take 6, although let's change it to positive, and divide it by 2, it tells me the charge of each manganese is a +3. So this would be manganese 3 oxide. Again, we like to put the parentheses around the Roman numerals because sometimes you have a non-metal like iodine that starts with an I. And if you don't use parentheses around the Roman numeral, the I for a Roman numeral and the I for iodine could get mixed up at times. Next one, PD, palladium. Cl, chloride. I believe when you looked at your periodic table, there's either a small +2 or a +4 over palladium. it has more than one charge. We have to figure out which charge it is. What is chlorine's charge? Again, we can always figure it out by knowing the non-metal. Chlorine is what? -1. And there's 4 of them, so that's a -4. And there's only 1 palladium. So that must mean that it is a +4. And again, the Roman numeral for 4 is IV. You can put the top and bottom on it if you want to. I try to emphasize that because year after year, people screw up on writing down the Roman numeral. That's why write it on the bottom of your periodic table in numerical order. People will put VI instead. So they get the question wrong. There is no partial credit on naming where at least you name the metal and non-metal, but you screw up the middle part. It's either right or it's wrong. So let's try not to make a mistake with that. Let's look at the right-hand side. The right-hand side is the exact opposite. If it gives you the written name, you can come up with the formula. This is just like last class. So Brooklyn, calcium oxide. What is calcium's symbol and charge? +2. Grant, oxygen symbol and charge.
O and -2.
So Matty O, what would be the formula of calcium oxide? CaO. The 2 charges balance each other out. Tin 4 chloride. Randy, can you find tin on your periodic table?
Boy.
I think it's number 50.
Yeah.
So what's the symbol for tin?
SN.
Now, Randy, if you look at SN right above it, it probably has a +2 and a +4 above it. It has more than 1 charge. Now, this could be leaving Randy thinking, well, how in the world am I supposed to know what the charge of it is? But when you look at the written name, it says tin 4 chloride. So, Randy, what's the charge of tin in tin 4 chloride?
4.
Yeah, +4. That's the entire point of the Roman numeral, the middle initial, is to know what the charge is. If there's more than one version, we have to tell you. Paige, what is chlorine's symbol and charge?
Cl-4.
Which means, Lydia, the formula for tin 4 chloride is SnCl4. Chromium 3 selenide. Emily, the symbol and charge for the metal part in chromium 3 selenide.
Cr, and then +2, +3, +6.
Okay, so it has 3 versions.
Oh,
Which version is it going to be? +3. Because it's called chromium 3 selenide. Alyssa, the selenide symbol and charge. Se-2. Once you're at the symbol and charges, you can either do the cross and drop method, or you can do the how many of this do I need to how many of that to balance out. Either way, Alec, what would be the formula for chromium 3 selenide? Cr2Se3. Cole, mercury 1 sulfide. Cole, I don't want you to give me the entire answer. I'll even help out. Mercury is Hg. It's element number 80 on the periodic table.
HG.
Sulfur is the letter S. So now figure out the charges. What would the formula of mercury 1 sulfide be? Kinsey, you got the next one. So it's mercury 1. We know the charge of that.
2.
And sulfur is a -2. So what's our formula?
Mercury would be Hg2.
Hg2S. Notice in the last question, barium nitride, the barium doesn't have a Roman numeral because barium only has 1 possible charge. Now, again, if you don't want to write out the symbol with the charge, I would recommend at least then, when it gives you the written name, to maybe write, hey, barium's a +2, nitrogen's a -3. Give yourself a little help instead of just immediately writing it down. Because some students will just call this BAN. But when you write down the charges, you remind yourself that can't be the case. What's barium nitride?
BA3N2.
BA3N2.